Right, so without further ado, I'm going to introduce you to Dave. No, I'm just seeing if I forgot the right name. There we go. Sorry, Dave. Dave is one of the leading cybersecurity people in South Africa, and he's going to be telling us a very interesting story. So I urge you to sit back and take some very good notes. Thank you.
Don't do cybersecurity, but that's okay. No problem. I think I'm the wrong speaker. I don't do cybersecurity, but that's all good. Just making sure. And is there a clicker? Yes, there is. Oops, close that. No. No, go. Oh my God. Thank you. Do you want to put that on? I'm all fine, yes. Oops. Like so. This way. I'm used to the normal. There we go. Perfect. Thank you very much. Now I feel like MC Hammer. So there's a common theme for those that want to do IT and end up there after 20 years, is that you have to have no hair. So I live that dream. So my name is Dave Ives. I'm currently actually a digital transformation specialist. If I do a bit of cybersecurity, but I'm a bit dangerous when it comes to cybersecurity. My IT team generally don't like me, but I've got a fairly large team. I also have you'll see it says Director of Karabina. So Karabina is a Microsoft solutions provider that does big data. We've done machine learning. We do some interesting work on. We've done data warehousing in BI for more than 15 to 20 years. We do dynamic CRM and a number of other Microsoft technologies, but you'll see that it says Omnia. So I'm currently seconded as the Digital Transformation Director for Omnia. For those that don't know who Omnia is, I'll give you a big rundown and you'll see a lot of real-life examples of actually using Internet of Things and talking a bit about Azure machine learning and the stuff that we're doing in some very, very interesting work, which I think is as important as education. It's food, and a very interesting, important world for us as well. So I think that to kind of give a sense of what is digital transformation, we're sitting in a cusp of a very interesting era. If you look at the population explosion and where we came from an 800 million to 7 billion, we've come through massive, massive transformation. And we always say that these transformations took place in various eras. So real life farming and farming environments took place many, many thousands of years ago. And we started to have an environment where we could now start to spend more time on thinking and less time on gathering food. And a lot of that work happened when we started to mechanize. We went through a massive industrial revolution. Some interesting things happened, but really only took off when we started investigating power and the ability of power to change the mechanized world that we live in. And power really was the instigator for us to now start to think about transmitting information and how we change our information assets and how we work. So today, we sit in a very interesting world where we're on this cusp of the 1960s when information technology really only started to take off. So the reality is many of us actually were working on the cusp of an industry that's actually very young when you consider from a mechanization perspective and other industries, we're actually a very young industry. Then there's this next industry, and apart from this PC era, we start to hear about it today. It's the kind of connection between cyber and physical things. We see it in the education sector, we see it in the healthcare sector, we see people investigating neurotransmitters, we see huge amounts of industry changes happening in the space. And we're actually in an environment now where we're starting to really see what this new era is really talking about around this Industry 4.0 and the connected devices and the ability to connect information in a very, very interesting way. It'll open up more issues, absolutely, but it also brings up a huge amount of data that we start to synchronize and syndicate to an organization. Now here's an interesting thing. So I don't have a degree in technology. I have a BSc in chemical engineering. I started off when I started working in the IT industry, I started programming PLCs and SCADA. I started automating control systems on plants, and I didn't know I was doing automation and controlling instruments My whole world sat with a zero, like 4 to 20 milliamps and 0 to 24 volts, and bringing analogs and digitals and counters together in making a factory automated. So my world over here started in the 1990s of the automation world, where we started to blend the ability to automate and control processes. I decided that was very boring, so I went and got a diploma in brewing, and I really enjoyed that because that's the first time I started to connect my degree with the things that I do. Because I drank so much beer while I was studying that I thought it'd be great to learn how to actually make and produce beer. I spent a lot of time making brews. I even became a yeast propagation specialist, CRP specialist, and a junior brewer. So that's my. I could only drink so much beer before my wife would actually throw me out the house. So I needed to get a real job. So I decided to get a job in IT. That's when I transitioned into the Dimension Data company after I was running a process control business, and started to realize that people in commercial IT earn a lot more money than people in industrial IT. So that's my only other feedback to you, is that you can definitely charge a lot more if you're in commercial IT. Even if you can use 3-letter acronyms, you're really, really, really well off. ERP, CRM, IoT, and AML, if you can use them. Opportunity to bring information together. And we're sitting. They started to realize that industrial revolution. So we have 12 sites at the ASAUDIT manufacturing facility, 65 sites worldwide, which we actually do blending, potency control, batch management, quarantining, controls. We ship thousands of products, and the products that we ship have to be managed. And when I say managed, HAZChem spec managed, which means that certain products may not be picked together, may not be moved together, may not be put on a truck together because they will explode. That sort of control is very, very diligent. We have these sites and depots where people could come and make their own weapons of mass destruction. So I have to monitor and manage every single item that we ship right across this whole business. We also have, which needs to be managed and controlled right from the time that explodes on the plant, and the actual physical fragmentation happened at a rock, right the way back to when it was manufactured as a detonator in a plant in Losberg. So some very interesting things. What's interesting about a business is that you can't automate a process unless you can instrument it. In other words, you must be able to manage things in this environment. And this is a very interesting world that we're living in. So when you talk about a digital transformation, you can't just put in a nice little ERP system and hopefully that things will pop out nice and I'll take 5 creditors clerks out my system. Generally, that's great. Or I can push onto my supplier stuff. That's great. I can automate and document stuff. That's great. But I have to do other things in a business. And this is where, especially in a business like ours, when I talk about Omnia and the work we're doing as Karabina there, is we're starting to see that we have to provide a lot more services to the farmers out there. There's farmers out there that want to understand, could we use drone technology to monitor their fields better? Could we have algorithms that help them with water use efficiencies? Could we plot curves of growth rates based upon certain nutritional capabilities that we put onto the farm? And back in 1950, one of the major transformations that happened in the agricultural revolution was the synthesis of ammonia. Because we no longer were at war, we stopped fighting each other and exploding everybody, we started using ammonia as a mechanism to extend the way that we can actually help people in the agriculture industry do more. And these agriculturists and agronomists are saying, how can I use interesting technologies like cloud computing, drone technology, mobile technology, to change the way that people work? And this is a very real thing. Now, a business transformation happens that there's a new digital challenge. There's a new way that I want to work. Unfortunately, for many of us that sit in the technology from an old space environment, this happens with our new mobile phones, new applications, that we realize that our people that we used to work with no longer work in the same way that our systems are constructed. And our systems are constructed from our own internal environment. And this is very difficult for an IT business that really wants to manage, secure, control, audit, build a logical schema model that mimics their business, but yet their customers have no desire to interact with that system in the way that you thought it would work. That's a massive challenge. And that's why you get this massive digital disruption. When you get an Airbnb that has a market cap of 14 billion and with no physical assets versus a Hyatt of a market cap of 9 billion and has all these massive hotel chains around the world, they're changing the way that people interact with information. And their digital assets and thinking is a complete disruptor in terms of their community. So it might mean there's a new digital challenge, a new way of working. We all understand the Uber opportunity, but how many other Uber disruptive models are out there today which are changing the way that people work? With a sit-in in the American Parliament recently, Periscope got massive, massive awareness because they were actually transmitting, instead of the land digital transformation, Periscope became a massive usage base in America because they were actually filming the sit-in in real time from mobile device. So you never know. These new disruptors happen all the time. I personally don't want to see Snapchat as a mechanism for most executives to talk today, because you'll see that things coming out their mouths and all sorts of other stuff. But there's interesting things that are happening in this new world. And a new digital challenge happens all the time. We also see that in many sectors that we're working with, and I'll talk about the tracking industry, there's a blend of new types of things that need to happen in that industry. You may start off doing one thing, but realize the data that you collect is more valuable than what you were using it for in the past. When the tracking industry started in South Africa, we had about 2% vehicle recovery. It's now less than 0.5%. So the vehicle tracking industry is no longer in vehicle tracking. They're actually in data sales to the insurance industry. They're no longer in the industry that they thought they were going to be in. And many companies today are realizing that the game changer across their sector is actually the data which they hold in their business, and not necessarily their traditional business model. We're also seeing that this new business model is disrupting many, many economies today. So it's going to change the educational sector for sure. Most of the students that we bring into our business will learn statistical R, for those that are learning R as a language. R is the de facto standard in Azure machine learning. They can download this on the EDX portal at any time, and you can actually go and sign up and get a certificate for statistical R on that environment. If you want to learn Python, they do that on that site. Most of our learning culture inside of our business today, of 150 guys and in the consulting space, is done digitally. And they sign and do all that work on that environment. So this is a massive, massive change in terms of the industry. The biggest problem we've all had is, if I give you this state of disruption, that the internet, social, mobile, we all know these kind of things. 3D printing, we're starting to look at the ability to 3D print. In some of our factories, we've got very old machinery. We can actually print seals and other items in the mechanical site to actually go and fulfill certain requirements on our plant today. So we're looking at investigating 3D printing, the holographic ability to have a look at a device. We have old factory equipment that we could actually use holographic opportunities to actually service that device and make it much better if we actually use this holographic technology. We're starting to see renewable energy, cognitive systems, nanotechnology, embedded neurotransmitters starting to take place, all this type of stuff, which is very interesting. And this is now great for any board to go, well, where do I start? Where do I start putting technology into my business? If I haven't even taken an instrument in my internal business, where do I go? With smart grids and connected cars and sharing economies, and if I'm in the financial services and blockchain says I can do a better job of managing a financial ledger in the cloud than you building a bank, interesting opportunities start to transpire in that space. So these disruptive scenarios are starting to take place. There's less and less argument from a board today that we should be connecting our sites and doing real-time processing. I have less arguments around spending money on networks, interesting enough. So if I look at where people are investing, yes, we're still looking in South Africa at connecting our sites and making sure our sites are fiber and enabled and very, very fast. If you don't do that, you can't deploy Office 365 and all this new technology. Absolutely. But the increasing. Okay. So the people that are making the spending decisions, the CFOs, the execs, and the chief officers, are actually getting older. And this is a massive challenge. The non-execs have actually gone up even further. And these are the people that are trying to understand, how do I use technology to change the way the business works? And we can understand why their motivations to spend money on technology from a funding model perspective has to be very, very solid today. And this is the problem that we have. If I go to them with a new idea, I have to have a CapEx request with a return on investment, with a estimated ROFI. There's a lot of new models. So as IT people, you have to start learning financial return models as well. And this is a very interesting thing. Sorry? And the thing is that corporate directors are holding their seats more and more. So today, and if you don't have a funding model to bring this money into the IT organization, you actually have a massive challenge. And the only way to bring the funding model into the organization is if you start at the edge, if it's going to change the way you work with your customers and change the way your products and services work. And that was a massive, massive learning for me. If you're starting with your core, spending money on the core and getting massive investment, there's not a big amount of money that actually gets liberated for that. So another thing that's also important in building digital transformation is that you need leadership capability, where management is very skeptical of advanced digital technologies. I sit with a bunch of engineers who can't conceive that we can model plants and do a better mass balance and energy balance in real time, and that I won't lose my stock, and I know exactly what's going to happen in real time. Today, interesting enough, in this day and age, realizing that actually this is very quite skeptical. They're very immature. They don't use all the technologies that we expect. So in IT, we come with our tablets and our phones, everything's connected, it's all there. They struggle, they still want a printed board note with multiple spacings and all sorts of interesting stuff. So we come with clever ideas on machine learning algorithms to change the way that agronomy is going to be using it, and they're saying, just print out things in a simple way. And this is the massive challenge that we have. Then you have certain companies, the digital, we call them fashionistas, the guys that want to do all the cool stuff, they buy the cool technology. Some of them are like the Ubers and the new digital disruptors. They'll buy the technology, they implement it, make the IT team do some new stuff, will program and use new technologies. But the challenge that they have is they have low leadership capability. So their business models go through massive changes in funding as well. We also find that the conservatives, when they create a digital vision, they can now start to spend money and they move into this digital mastery space. But what we're finding with this is we're in this conservative space now in the company I'm working with, where we're investing in technologies, we throw a few ideas out there, we bring new technology in, we test the concept, we bring the governance in, we test all the mobile devices, the security models, everything slowly, and we slowly start to move them into a strong digital culture. There is a lot of fear. There's a massive fear. So Industry 4.0, the fear is that we're going to lose huge amount of jobs in the industrial environment. So those that in IT are going to take up the jobs in actual industry, and that's the big challenge. So many companies are facing this. And I think what we're doing over here, if you could manufacturing, consumer packaged goods, pharmaceutical companies, very much in the beginning space. Insurance, also conservative. Utilities, the guys that are digital masters, high technology, banking, new banking models, those are the guys that are starting to invest high in digital mastery. The other interesting ones is the new travel, telecoms, those guys, tracking guys, or the fashionistas, they're actually having to realize now, they're having to pull back and start to change their operating business models. Now what we're doing in our business at the moment within Omnia is saying, how can I change my manufacturing environment? How can I make it more efficient? How can I get overall equipment efficiencies right? How can I use the sensors on the devices to pick up automatic determination when a machine should be serviced before the failing actually happens? The cost of downtime in our facility can cost anything up to R1 million an hour should an item go down. And that's a massive amount of cost to our business. We're also looking at how we can then focus on employee productivity. How can we give people the technology to be more effective in how they service the customer? We're very much in that sort of space. How can I modernize the systems and a process to make it automated right the way from when I collect the data right the way through into my system? Many IT people build the system as if somebody has to enter more and more forms and more data. And you think that it's important to trap as much data at point of presence. What if I could trap that through the streaming? What if there's a GPS device that will automatically augment that data and give me enrichment on that data because the device can handle some of that content as well? So we're doing a lot of the changing of the products and services to change our industry. So Omnia as a business, I'll talk about that, is saying we're in the commodity market. We give people on the farm good fertilizer. We sell chemical products. We sell explosives and detonators. That's great. But the problem is, as soon as the oil price tanks, our cost of our products it goes and actually it tracks with urea pricing and the global oil pricing as well as foreign exchange currency. So that's a massive challenge for us. So how do we provide more service and change the way that we offer our services and products to our customers? And that's something that we've obviously termed our service through knowledge. So the more that we know about our end users, the farmers, the guys that go and blend and make the shampoos and dishwashing liquids, if we know more about them and the stuff that they're doing by using our products, the better off we're going to know about how to service them better. And this is where our digital transformation is taking place. And we're using data to improve the way that we deliver this value to our own business. There's 4 main areas that we're focusing on. Engaging our customers. So that's how do we understand our customers better, their buying cycles, behaviors. We are actually instrumenting all of that in our business. We understand what channels they're working through. We've opened up new source, a new way for customers to come in. Before, a pickup would take nearly an hour 45 because we had to do Road Traffic Act, HAZChem and checking. We've got that down to a 50-minute turnaround cycle. What that did is we were able to shift in one business unit. We could only service 200 customers in that channel. We can now service 800 customers in that channel, and we can scale that channel quite quickly up to 1,600 or to 2,000 customers just by changing the processes and understanding more about the customer. We also educated the customer, gave them a mobile app, told them what products were available. We told them what the price lists were. Simple stuff, actually. Very simple stuff that changed the way. We also helped the customers with things like pre-order. So we said, listen, now, if the product's not available on our price list, well, if you pre-order 24 hours, we'll have it picked, packed, moved, and ready for you on a pallet. When you arrive, the item will be there. So we've really done a lot of work. Now, this is a company that is about, hey, if you want my stuff, send me an order on a fax. And maybe I'll drop it at your place in 3 days' time when my trucks are full kind of stuff, to let me provide you with a completely new service in a very different way. This is the same company that's opened up in Zimbabwe, Zambia, and others with little fertilizer retail chains where guys can come just with a bucket if that's all that they can afford and actually have a direct process through that. It's very, very interesting. And that requires you to have some instrumentation and some controls and points of sale to mechanize that whole process. We looked at our employees. Our employees were very, very old school, printed everything. Many of the secretaries actually didn't, and the assistants never had a laptop. If they had to do extra work, they'd have to come in on the weekends. Yes, that's how things would work. In 2016, this is the reality of some businesses out in South Africa today. Have to physically come to the South African office, to their head office, and do that work. So just by putting them a mobile device in that environment and just simplifying their processes. And then also, the biggest challenge that we have is this new technology. Teaching them how to use it more effectively is a massive challenge. We've put dashboards in and real-time processing analytics. People don't know how to look at it and realize how to use that information. So what are some of the big things you guys have to do is put reporting analytics in there. How many people actually know how to read a dashboard, understand it, click, drill down, sort highest to lowest, move things across? They don't know how to do that, interestingly enough. So we sit with a massive challenge from an IT perspective. The stuff that we do and the training of employees, massive. Optimizing the businesses, this is operating models. That's what I spoke about, where you can now process real-time environments. We've put a lot of work into optimizing our warehouse management, our distribution. Everything must be simple. Everything must have an asset tag. I can pick it, pack it, move it, license, drop it, move it across. And this allowed us to look at transforming our products, which I'm going to talk about now. So when you want to transform your products and services, here's a great company. So some of you might see Ecolab every time you walk around, and they do everything from sanitization to water cooling technology. Here's a company that's using big data, digital transformation for changing the world. So not for many, many years, and they have thousands of customers worldwide. And they have set themselves a huge target of being able to save 300 billion liters of water by using technology and save water. Now, water usage is a massive, massive challenge in the world over. And they reckon with their technology, they can improve the conversion, the saving of water, the reticulation of water, and changing the way that things start to work in their customers. And they outsource the service completely to thousands of customers worldwide. When I give you the data points and you look at the video, you'll see it's a massive environment. As an engineer, for me, this is the stuff we used to work on. is conductivity, pH meters, and this is the stuff they've instrumented directly at their customer sites to improve the ways that things work. Just think about the things that you can do in your own environment when it's sensor detection technology, which is available very, very quickly today. You can connect anything. They have real-time monitoring at every single site worldwide. They have a global center which looks and brings data back and streams that data back. They're able to pick up a fault on a water line before the customer can, and actually discharge a technician to go and service that in real time. So this is a very interesting blend of bringing information, geolocation data, types of data, where the challenge might have happened, and actually being able to deploy service back into that environment very, very quickly. So they collect 27 billion data points per year. They're collected into a massive data warehouse. Yes, it is built on an Hadoop cluster, built on the SQL Azure machine learning, in 123 countries, and they have thousands of sensors that stream this technology through all the time. They can also start to predict how many gallons of water they'll save your business based upon efficient water treatment in your cooling reticulation circuit or any other circuit worldwide. They deliver updates to the system in terms of improvement, so their chemical dosing facilities can be automatically trimmed from a remote center in India or anywhere in the world. So they can actually change the dosing material and pumps from somewhere remotely connected, not in your geolocation. Very, very interesting technology. So I think what I'll do is I'll just actually forward through on that one. So I think what we can do is, I know we're running short on time, so it's no problem. So I think if you have a look, and I'll leave the video case study with you, they have set themselves some very interesting and difficult targets when it comes to treating and using water more efficiently. Now in South Africa, that's another interesting thing for us, and why I went and visited these guys at Nalco Ecolab to see how they thought about using data more efficiently. And they said typically when they started their data in their environments, and I'm a Ralph Kimball trained data warehouse specialist with schemas and standards, and I've always found data warehousing to be very exciting until you deliver the reports and then nobody uses the report that you thought they were going to use. They start to ask more queries and drill downs and stuff. And I think that that's been an interesting thing. And they said they started with standard reports. They started with what happened and how often did it happen with counters and issues in their environment. Then they started to say, where exactly is that problem? With the ability to drill down to more detail. Then they started to say, why is this happening? Is there something that from a pump perspective or the impact analysis? And this is where you now start to expand your data elements. Is this because of the weather? Is this because of something else happened in the environment? Is the condensation in the cooling towers causing the following transmission around our environment to change? And they're now able to do statistical analysis. They're using statistical R to model the full water cycle and their mass and energy balances. And then what happens if this trend continues or extrapolates? What's the impact going to be? And what's the best practice? They can take best practices now and start to use that as a method to design the next set of plants when servicing their customers. And what's the predictive? How often will these things happen? So if you have a different, for example, if they're working in different companies that have different cyclical natures, they can actually predict when they should be sending more chemicals or less chemicals to different sites or improving their reticulation cycles. They're looking very much at the optimization cycle. What's interesting about this is when you start to bring this data together, you have to have master data management. You have to have a lot of very good controls and reference data in your business. Many businesses I talk to today don't do master data management or definitely don't do it very, very well. And many systems out there don't talk in terms of reference data to another system. What you might have as a student reference ID here in one system may refer to something completely different in another system. And when they started to blend systems together, the level of granularity of data was different, but they started to work on a very strong item called an item master, product master, and they had very, very definitive technology to actually make sure they'd mastered information across their platform. No matter what type of sensor you brought in, the IDs, the tags, the information were syndicated and understood between the different systems. So one of their fundamental things they were able to do in building out this environment was their master data management platform. Now when they go to any customer and they reference that data, all that information is verified and they can aggregate it in any way they like because of their master data management. And this is where, when you want to bring IoT data in and reference data in, the ability to do that today is actually so easy. I remember writing drivers in C++ and everything to bring data in. It is done so much easier today. You can tag an item, pull the information in and digitally transmit on a cloud interface very, very quickly. And it doesn't matter what type of data it is, you can stream that data very quickly. The challenge is it's so easy to do a proof of concept. When you scale it to thousands of devices and items, it becomes almost impossible to manage. So this is an important thing and something that we're really worried about. In our business, we have these massive challenges. So if you have a look at the Omnia business, I think it's a very different way when you want to start bringing your data together. So our agricultural sector services a couple of thousand customers and has more than 3,000 product ranges. We have everything from granulated products to liquid products. We will do certain pesticides as well and other specialty chemicals. The bulk mining explosives business actually will do detonation, small debts, large debts. It actually does down to, it'll drill a hole, an outsourced blasting mechanism for customers where we actually fill with an emulsion, add the debt, and do a sequence blast, which I'll show you now. And the chemicals business ships 2,000, used to ship nearly 4,000 products worldwide, break bulk movement down into very, very complex processes into a number of customers and services more than 4,500 customers just in Africa alone. So combined thousands of customers and fairly complex digital business requirements. If you have a look at what we're trying to do, and I'll talk to two business units and I'll skip out the proteochemicals business. But in Omnia, there's 75 agronomists that in real time can tell you everything that you need to know around a way of running a farm, managing a farm based upon the types of crops, whether it's soya, whether it's maize, whether it's a new derivative of red onion, how to plant it, seed it, manufacture it, what watering type, what soil, what nutritions. They've got mapping technology to look at efficient water use algorithms. And there's years and years of IP all mapped in Excel, believe it or not, where they've got everything from a growth curve for every single type of nutrient and every single plotted against that particular item. Many years ago, what the guys, the agronomists would do is if they saw that a millie wasn't looking great, they would take a picture and based upon that discoloration and size, they put something next to it to look at the size, they would be able to tell you if it was on the right growth curve and what they should be putting onto that plant. Today in machine learning, there is an algorithm that you can just touch on and actually will go image recognition directly for you. You'll be able to take that picture and in real time compare it to a growth rate and be able to then will tell you exactly what you should be doing in terms of adding more nutrients or doing something to that particular field. So there's something very interesting that can be done in this environment. So the value proposition is the agronomists now we've taken a lot of the IP and they're now putting it into digital processes. And now the agronomists and the guys that work around the field actually work with mobile devices. They map physical field environments, and I'll talk about the work we're doing there. And then in the blast mapping is a very complex process because if you don't map the items properly and blast in the right sequence, you're not going to get the fragmentation right. And in a mine, if the fragmentation is wrong, you will destroy everything from the yields, the hoppers, the mills. In fact, the mine won't run efficiently. So your ability to blast efficiently and run that process is very, very difficult. And I'll talk a bit about the work in the blasting space that this team has done. Phenomenal thinking when it comes to machine learning, connected devices, taking video pictures of that environment. Very, very exciting. So this is just some of the big data statistics machine learning platform that we're now working on. So we've now got something called OmniPrecise, OmniBio. We've got water use efficiencies and something called a nutritional use efficiency matrix and curve as well. This is all IP that's been sitting in the business for hundreds of years, which will actually understand a bunch of details around the particular farm and the farming type. What's interesting as well is they've just started a division called the Emerging Farmers Division, where they'll actually go and fund emerging farmers and assist them with the best practices in the farming industry. And we're actually tracking a lot of everything from what types of assets they should have, the standards in their farm, and there's a bunch of algorithms that we're obviously also supporting some of the new farmers in that space. And this allows us to now have financing, insurance, because we can actually take a better risk. We can help the farmers and prove that farmer is actually a low risk back to the bank. And the foreclosure is a massive issue for farmers in the space because they need to prove back to the bank that that asset is going to turn. And that's a massive challenge for people. So with using our algorithms, we can actually start to bring in new ideas and thinking in terms of back down to financial institutions. That's how differential we're able to do our thinking in that business now. So yes, we'll take soil samples, yield monitoring. We've also tested drones and bringing back drone technology in so we can map the farming fields and the field use efficiencies much better. All the weather station data and then bring it together. Very, very interesting. So this is the type of agronomic data that we're building in and bringing back to the R&D environment. This then flows to the type of granulated item that you'll need to actually send through to that farmer to efficiently use on his what they call fertigation mechanisms. This data over here, very interesting enough, we took a bunch of data from the farming industry in the wine. So we took a bunch of viticulturists, we added pH, sugar, and we were able to within a couple of hours take their data and show them the direct correlation between area, sugar, because you know Carlitsdorp has Sultana grapes, has the highest sugar, and what they should be using to spray in that area, because it's a rocky area, the types of what they call these verlangde perlt. It's like a massive item which goes and sprays those areas. And what type of liquid-based fertilizer would work in that area. So the correlations are very, very interesting. And I'm testing my team to doing more and more data in this space to change the way this business works. Our next and look, one shot. It's a massive, massive blasting technology. But this effectiveness of this environment is huge. So they basically will map out the full blast wall, underground and open cast. They'll actually manage all the trucks that actually do all the actual drilling. We'll actually go and geolocate the code, the drilling and the drilling depth. We'll actually manage all the amount of HEF, which is the emulsion which gets published in, the debt sequencing. Everything will be monitored down to the endpoint where we'll actually do fragmentation analysis on the size clustering of the rock material. So this is interesting because the only way to do that currently, the algorithm that runs, is actually uses things called shadows. So it'll pick up the amount of shadowing on the actual rock to pick up the algorithm. And the algorithm will say, yes, we have got the right particular fragmentation. And from there, we'll know whether the blast was successful or not. Then that feeds into the mining system, which then goes into downstream. So you can see we're looking at blast performance monitoring and metrics. They've actually got a whole bunch of work they're doing in the mobile device back to their customers to look at how much they've actually saved that customer by blasting effectively. So this has been a challenge. We're actually using the Azure environment and a few other areas to bring the information back. So how do you get what are some of the fundamentals? So I run an ERP team of 15. I've got another team of about 35. The only way to get projects like this over the line is extreme ownership, and you have to fight with everybody all the time to do stuff. It's an exciting thing. Read this book, Extreme Ownership and Lead to Win. This happened with the chief financial officer of this business. He has, when I think of extreme ownership, every project that we run, everything that we do, he knows about and he drives. Extreme ownership is a critical element. You have to find best practices. You have to go and learn. We've had to teach ourselves statistical R and algorithms, and we're now partnering with a bunch of computational grads, honors students, to go and figure out new algorithms to make this stuff work. The answers do not sit in the group IT team. They sit with the agronomists, the scientists, and the other guys. Okay? So our group IT team has to learn how to partner and build a team to get this stuff to work. The group IT team, actually we called Omnitech now, doesn't have all the answers. Even my smartest computational guys do not have all the answers. They have to work with these other teams and they have to work as a team to solve the problem. You have to work with guys that understand drone technology and digital telemetry technology to bring the data in. You have to find out best practices out there and use the teamwork environment. You have to be expedient, and sometimes you have to simplify and say, let's just focus on one thing. So we did the water use efficiency, then nutritional, then get the mobile devices out, and then we started to use simplification was critical. And you've got to find ways to simplify a very complex topic and make it as simple as possible, get the focus, win on that focus, and then get on to the next one and focus and focus. And you have to simplify. When we talk to the agronomists, they want to do everything all at once. We have to simplify and say, let's just focus on these environments. The block, everything all at once. How do I get Expo Plus working, plus the loggers working, plus this working, because I know I need this data to get there. Simplification is critical. We've chosen a platform, so it was simple for us. But if you're not in too many platforms, yes, we do write Python scripts and other stuff as well to get our stuff to work every now and then. But once you've chosen a platform, you've got to stick to it, you've got to use it to the ultimate core. You have to learn all these new stuff that's happening in the space. This is tough because these guys, Google, Microsoft, Amazon, they move so fast in the space. It's difficult to stay up. Our whole dev technology front end for mobile environment has completely changed at least 2 or 3 times. And we've had a really, and we started with Android, then we moved to Apple. Apple's a massive closed community. We couldn't deploy app well enough. We had to go back to Android. Then we've gone back we've done a few things. You must be able to make a few mistakes on your platform. And that's an important piece. We have approached an agile environment, and agile does not mean you don't write a business requirement specification, document, and do stuff. I just want to state that for the record for those that do stuff. If we write, we do a lot of agile development, but we document everything. We've used the methodology for that, and we do product backlog management as a prioritized product owner. And if we don't get ownership from the business to read this, we stop the project immediately. If you don't read it, come back to us with feedback, we'll stop the project. If you're not going to own it, we're not interested in helping you. Interesting stuff. If we don't have a business owner who sits in our sprints and gives us feedback, we'll stop a project. If he hasn't got the time to read a document and give you feedback, then you haven't got the time to build it for him. And with that, I want to say leadership best practices and principles. Clarity, make everything simple for the business user. My job is to take the complex stuff from the group IT team and make it simple. Make sure everybody understands it. So sometimes I have to use engineering terms and not IT teams. I have to get people excited about the stuff that we're doing. I constantly present to the board. I take my IT teams up there and I say, go present, go talk to them, go show, go demo, get people inspired, go to the forum. Very good at bad communication, and that's a problem. We have to learn how to get out there and get people excited about the stuff that we do, and you have to build organizations that are stronger stronger tomorrow than they are today. You've got to communicate. So you've got to share with the teams as well. So the first thing I'm doing is I take all my IT leaders and I put them on communication skills courses, teach them how to stand up in front of the guys and present and demo. We review their stuff that they do, that they can talk to business guys. We've got a bunch of engineers who don't want to hear tech terms, but they want to be excited about their business. Innovation is important. So what we've got is a mechanism that we have to drive a certain innovation criteria. So we have to have stuff that people love. So we look on the sites, we've done everything from action boards, digital action boards, be excited about it, inspired one of our plants. Next thing I knew, all 12 plants wanted it. So that's an important thing. So you have to be tenacious about this and tenacious in the face of adversity. And with that, I'm done. Thank you very much.